Imagine a weapon that doesn't rely on explosives. Instead, its destructive power comes almost entirely from one thing: speed. It sounds impossible. After all, we usually associate explosions with massive damage. But physics tells a different story. When an object travels at several times the speed of sound, its kinetic energy becomes enormous. That means a projectile moving at hypersonic speed can release tremendous energy simply by striking its target. Modern hypersonic glide vehicles are designed to travel faster than Mach 5 while maneuvering through the atmosphere. Unlike traditional ballistic missiles that follow a predictable arc, these vehicles can change direction during flight, making them much harder to track and intercept. Their speed alone creates one of the biggest engineering challenges in modern aerospace. At those velocities, air doesn't simply rush past the vehicle, it compresses. Temperatures around the vehicle can rise to thousands of degrees. Engineers must develop advanced heat-resistant materials capable of surviving conditions that would destroy conventional aircraft. Navigation becomes another challenge. Communication systems can struggle because superheated air surrounding the vehicle may interfere with radio signals. Even steering at hypersonic speeds requires extraordinary precision. A tiny adjustment can change the flight path by miles. Some advanced military concepts also explore kinetic-energy weapons that rely on velocity rather than explosive payloads. The principle is surprisingly simple. The faster an object moves, the more energy it carries. Enough speed, and the impact itself becomes the weapon. That's why aircraft carriers and other high-value military targets have become a major focus of hypersonic research around the world. The goal isn't simply building a faster missile. It's creating systems that are harder to detect, harder to intercept, and capable of reaching distant targets in a fraction of the time. Of course, developing these technologies is incredibly difficult. Every material, every sensor, every guidance system must survive conditions few machines have ever experienced. And despite rapid progress, many challenges remain before these systems become widely deployed. But one thing is already clear. The next generation of military technology isn't just about bigger explosions. It's about mastering physics itself. Because sometimes, the most powerful weapon isn't the explosive, it's the speed.